simplifying radical expressions, a few things you need to keep in mind. You have a pretty little checklist here. So these are all things you need to look for when you are simplifying. The index n is as small as possible. Okay, so it's either 2, 3, 4, 5 rarely, but maybe. The radicand contains no factors other than 1 that are nth powers of an integer or polynomial. So if you look back at your factors here, they can have the 1 underneath, obviously, because if you divide it by 1, you have a 1. So that can always be there. The radicand contains no fractions, so you can have a fraction underneath your radical, and no radicals appear in the denominator. So that's, we're going to get into rationalizing later. So when we're multiplying radicals, if you notice we skip example 2 because we're not going to be doing that. So here in example 3, if you multiply radicals, basically you're going to be multiplying whatever's on the outside times the outside. And then after that, you'll be multiplying whatever's on the inside times whatever's on the inside. Alright, so here we have is 6 times a 4. We're going to multiply those on the outside. Underneath your radical, well, we have a 2 times an 8. You have a p to the 8th times a p to the 1st. So you got to group like terms, basically. You have a q to the 7th times q to the 2nd. So when we simplify this, we get a 24 on the outside. Underneath, you have 16 p to the 9th q to the 9th. So what we have to do from this point is we have to simplify like we did in example 1. We're going to have to split these problems up. If we have a square root, we're going to have to simplify the 16 by itself, the p by itself, and the q by itself. So I'm going to rewrite this as a 24 times square root of 16 times p to the 9th. I like to see my terms all separate, times square root of q to the 9th. So you simplify. 24 square root of 16 is 4 times, this is going to become 9 divided by 2 is a p to the 4th remainder of 1. You don't have to put the 1 if you want. But then you also get a q to the 4th remainder of 1. So your final solution ends up with anything that's on the outside you multiply together. 24 times 4 gives you a 96. P to the 4th, q to the 4th, and then you have a square root of p times q. So that is an operation, but then you have multiplying, but then you have to simplify afterwards. Same thing happens here on b. You're going to multiply the 5 times the 5 or the 5 times the 1 on the outside. But here we're going to have a cube root. So we're going to take 100 times 10. And then you have a to the 2nd times a to the 1st. So when you simplify this, you get a 5 on the outside and a third root of 1000 a to the 3rd. So if we simplify what's underneath our cube roots, and we keep in mind we're looking for perfect cubes that go into 1000, and they're like, oh, hey, the third root of 1000 is actually a perfect cube. And then if we have the cube root of a to the 3rd, that's also a perfect cube. So we end up with 5 times 10 times an a, which is 50 a when you multiply this through. So finally we get something that's simplified and we don't get any radicals. If we did have a radical, it would be a cube root though, so don't forget your cube in that case.